Hello world, again, my name is Eric Vicenti, Code Eric as it is, and today let's talk about the Zurv API, and let's get into a tech demo where we're actually going to create a custom server that does some special stuff that we want to do. So that's what what we're doing today is we're going to be creating a server, and we're getting highly technical. So I do highly recommend that you actually follow along on the code base by checking out the repository. It's open source here on GitHub. So everything that I'm going to do, not only will you see the results of it, but you'll be able to follow along in the same code base. Okay, here in our code base, zServer is the existing server, but we want to create our own server for demonstration purposes, so we'll call it demo server. We need to copy a few files in. For example, we'll copy over the tsconfig straight from zServer. We also need a package.json. So this package.json has mostly been pasted from zServer. We're going to want to rename it so that it has a distinct name called demo server. And instead of an index.js, let's create a different file name in here called demoserver.ts. And now we can create our demoserver.ts file. So this is what the very basic server looks like. It has a function to start zServer, where we tell it what port we want to listen for, and we give it the API, which in this case we've named zroot. So what is zcontainer? What kind of API does this expose for us? Well, for now, let's just try running it. So I'm going to hit save the package.json file, and as you can see what the package.json file is going to be doing, it gives us the ability to dev, where we are concurrently building and running the built version of the server. And in order to build, we use esbuild, and in order to watch, we are using nodemon. But you don't have to worry about this, really. All you need to know is the dev command. So we're going to go into our command line, and we're going to need to choose the right workspace. So it's yarn workspace demo server, and then the command that you want to run, the script that you're running inside of there. So it's the dev server, or the dev script. Here it's upset that, wait, do I know what this is? Okay, actually the first time it ran, I think it failed because, I don't know why it failed on the first time, but on the second time it runs just fine, and it should actually be changing things as we make changes to it. So it says it's listening on localhost 3999. So I'm gonna go over to Insomnia, which is, a web client that allows us to travel, the interwebs, the HTTP interwebs. And if we query for the root path, there's actually nothing there. And the reason why is because this is a Z API, it's a Z API. There's .z, and the entire API is available behind .z. And the reason we do this is so that we can also use the same server for a general purpose web browser front end, but it has the full API on the same host. So here you can see that children is an empty array. So that's what we're getting back out of our container. So it is empty, right? Now this Z container actually is a composable thing. So we can take something else and we can put a container inside of the Z container. So for our example, let's create a very simple calculator where we're going to keep a number inside of the server's memory, and we're going to allow the API users to add values against that. So that way we can kind of have a running value. It's a very simple example where you're able to get a value, like a number, and you're able to perform an action, like adding. So let's call it the calculator. And just for the sake of, demonstration, this calculator is another Z container or Z container. I haven't figured out how to say this thing yet, but it's called calculator here. And we can see that all it does is it creates a new subpath for us on the API. So let's go back and query for .z, and it says there's calculator here. So if we query for what's inside of calculator, we can see nothing. Again, that makes sense because we haven't actually put anything inside of here. So let's create our value. We have our internal variable here, and we can create something new inside of here called value, and that is going to be a create zgettable. Now a zgettable is a value that you're able to get, but it includes the schema. So inside of the zgettable, it knows what the schema is, and that's what we pass here as the very first argument. We're passing in the value schema. So we're going to say that this is going to be a number, a type number. And because this is JSON schema and the schema never changes, we specify as const. And this is really important so that the type can be inferenced from the schema. So now we need to provide a getter, and you can see that the TypeScript is hinting to us. It says we need to provide an async function because it's going to return a promise, and the promise is going to resolve a number. Now in this case, we don't need it to be async, but we'll do it anyways just because we can. And we're just going to return the internal value that we have. So now we should be able to query for a number from the API. So here when we query for calculator, there's something called value on it. And we query for /value, and it has our number 0. Now, the schema is also available here, and everything in the Z API has a .type behind it. So we can query for .type of the value, and we can see the JSON schema for the value. And we can also query for the .type of the other things. They're just a little less interesting. Like here's the .type for the container that specifies, this is the type for the whole calculator, and it specifies that there's a value here. And now we can potentially add other things to our calculator, now that we know that the value can be gotten. We're still not able to interact with the value though. So let's go ahead and create that action. Let's just call it add, and it's going to be create Z action. Import that from core. Now, when you define an action, you need to tell the Z system what the payload is, like what the data is being sent to the server, what the response is, and then you need to define the async handler for the action. So what is the input for this action? Well, it's another number, right? So we're just going to copy this number schema here. So that's the input value. And the output value, well, let's just go ahead and return the new number. So we can also basically have a number as the response value. And now we need to go implement this function here. You can see that the type is unhappy because we're not actually taking in a number and returning a number. So if we took in a value of type number and we return that value, the type safety checks out. By the way, this is a very weird type issue here that's going on. Excessive stack depth comparison. Don't worry about that error. Actually, TypeScript is continuing to work through it and work past it. And I'm looking into this. But for now, you need to just deal with that and the fact that it is still checking the types. In fact, if we return something other than a number here, it would be complaining, in addition to this error, it would be complaining that you're not returning a number, and yet you've specified that the zgettable is a number. And we use a library called JSON schema 2ts under the hood in order to make that happen. But keep in mind, this adding function, it's not actually working yet. So remember this internal value. Let's make it so that the internal value is plus equals the value that's being passed in. And we want to return the new internal value. And plus equals just kind of adds to the existing value there. So let's see what our API looks like now. Well, actually, forget about this API. This is cool and all, but the whole point of doing everything here is so that it can show up inside of our Zerv app. This way, we've implemented our API, and then automatically we get a nice user interface for it. Or nice is subjective, but we get a user interface for it. We created a new server, but we haven't connected our app to this server yet. So I'm going to go into the server connections, do new server, do demo calculator server. Localhost port 3999. Okay, did I spell calculator correctly? I don't know. In any case, there's the special, we're going to tap into server setup and tap on dynamic API, and that's how you get access to the raw API. And that is basically the equivalent of querying for, .z at the root of your host. So now we can tap into the calculator, and it knows that there's a value and that there's an add, and the value is something you can see. The add is an action. Here we can see the value is currently 0. We're going to go into add and add a certain number, whatever it is. This is the response to the action. So it's responded with 12. So we've added 12 to 0. And yes, the value has persisted. So here we've gone and created a very simple user interface. What's great about this is that this form is dynamically defined from our action. So here, if we wanted to add a, so this is the payload that we're being provided. So here you can say title is the number to add. And now if we come and reload the action, we can see that our title is being applied to this field. So this is one of the advantages of using JSON schema on the server, is that your front end can be automatically created, and it's pretty nice and pretty easy. So thanks for taking a look. I hope you've had fun experimenting with the Zed API. I know I've had a lot of fun getting it to this point so far, and it also has a really long way to go. It's not very well documented, and there's a lot of improvements that I've got to make to it. But we're building in public. I'm glad you've made it this far in the video, so thanks for watching and thanks for contributing and participating, because I'd love to see you show up in the community. So I'll see you around, and I'll see you in the next video.